Here we're given a piecewise function and asked to determine if the function is continuous at x equals 3. To determine if something is continuous given a function, you really have to use the definition of continuity. So the mathematical definition of continuity says the limit as x approaches some number, they just call it a, of f of x, does that equal the actual function value, the dot on the graph? What I always say is, does the limit equal the dot? Does the limit value equal the y value at that same point? So we'll start off, I always start off by doing the limit portion of this. So we're looking to find the limit side here. So to do this, we would want the overall limit as x approaches our value of 3 that they gave us of f of x. Whenever you're being asked to determine an overall limit question is really asking you to determine the two smaller limits. They want to know, does your left-hand limit equal the right-hand limit? Are those two values the same value, or are they something different? So coming through and determining first our left-hand limit. So the limit as x approaches 3 from the left of f of x. Well, when you're dealing with a piecewise function, you got to figure out which part of that function are you supposed to be using. We want things to the left of 3. So if you think about that in terms of a number line, if I've got 3 right here, things to the left of 3 would be the things that are less than 3. So for our left-hand limit, we're going to use that top equation of x plus 2. I always just go ahead, you want to try what I call option 1. We're just going to plug in the x value and see what we get out. And so plugging in our x value here, we would get 3 plus 2. We get an answer out. We get an answer of 5. So our left-hand limit is 5. Now we need to go find the right-hand limit. So coming back to that same equation, you'd say limit as x approaches 3 from the right. So things to the right of 3 would be the things that are greater than 3. So for the right-hand limit portion of this, we would want to use the x is greater than 3 piece. So that would tell us that we want to use 3x minus 4. Again, go to option 1, just plug in that x value into your equation. I would get 3 and then plugging in 3 for x minus 4. So that's going to give me 9 minus 4, which is going to equal 5 again. So what we can see now is that our left-hand limit and our right-hand limit do equal each other. And so that tells us that our overall limit is going to equal the same value. So right now we know that our overall limit as x approaches 3 of this equation is going to be equal to 5. So we have the limit portion of our answer. We know that the limit is equal to 5. And now what we have to go find out is we need to go find out that dot on the graph. What is that actual function value? So we need to go find what does f of, and then our x value that we're working with is again 3, what they gave us to work with there. Going to your piecewise function, you now want to know what happens when x actually equals 3. So here the equals 3 is this portion. That tells us that this is actually just equal to the constant 5. There's no x to plug it into. Normally if there was an x to plug it into, that's what you would do. But out of that, we just get 5. So our dot on the graph, our y value, is also at 5. Now we can draw our conclusion about our continuity. Since our limit value was equal to our dot on the graph, those two things are equal. Therefore, it is continuous at that specific value at x equals 3. So whenever somebody wants you to determine if something is continuous, you always have to go back to that definition. And you start by finding what is your overall limit, get a value out for that, and see if that's equal to where you would put the dot on the graph, the function value. If they're equal, cool, it's continuous at that point. If they're not equal, fine, not continuous at that point. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.